everyone. Welcome to the 4th grade math channel of Sun Devil Learning Labs. My name is Miss Houston, and today we're going to be talking about decomposing fractions using a tape diagram. So our objective for today, and you guys can go ahead and say this with me, I can decompose fractions and whole numbers into smaller unit fractions using tape diagrams and addition or multiplication equations. So we're going to practice this method set using both addition and multiplication, and we're going to compare them, see what's similar about them and what's different about them. The only materials that you're going to need for today are paper, pencil, and an eraser. So let's get started. For our first activity today, we're going to do a read aloud. So we're going to read this book called Jump, Kangaroo, Jump. It's written by Stuart J. Murphy and illustrated by Kevin O'Malley. So let's follow the kangaroo as he goes on his adventures. It's field day, yelled Kangaroo. There were 12 campers in all, a kookaburra, an emu, 2 platypuses, 3 koalas, 4 dingoes, and Kangaroo himself. They alarmed up as they waited for Ruby, the kangaroo counselor, to start the events. Finally, Ruby blew her whistle and said, "We need 2 teams for tug-of-war. Let's split the group into halves so that each team has the same number of campers." They counted off into 2 teams. There were 6 campers on each team. Each team had half of the campers. 6 is half of 12. This means that we started with a group of a total of 12 campers, right? Because when we divided them into 2 teams, we had 6 and then 6, which equals 12. The campers tugged and grunted, and then they tugged some more. Both teams tugged very hard. For a while, it looked like Kangaroo's team. Oops, sorry guys, let's go on so you can see it. Okay, there you go, now you can see the book again. For a while, it looked like Kangaroo's team might win, but with one giant tug, the other team won instead. Again, Ruby blew her whistle. Now it's time for the swimming relay race. There are 3 lanes in the pool. Let's split into thirds so that we have an equal number of campers for each lane. They counted off into 3 teams. There were 4 campers on each team. Each team had a third of the campers. 4 is 1/3 of 12. They kicked and splashed, and then they kicked some more. All the campers swam just as fast as they could. This time, Kangaroo's team came in second. Ruby blew her whistle once more. Next, we'll use our 4 canoes for a race on the lake. We need to split the group into fourths so that we have an equal number of campers in each canoe. They counted off into 4 teams. There were 3 campers on each team. Each team had a quarter of the campers. 3 is a quarter of 12. They paddled and pulled, and then they paddled some more. They paddled just as hard as they could. They did their very best, but Kangaroo's team tied for last place. He wished that he could win just once. "Cheer up, Kangaroo," said Ruby. "You still have one more chance." "Okay, everyone," Ruby yelled, and then blew her whistle extra loud. "Let's line up for the last event of the day, the long jump. This time, you're on your own." Each camper took a turn jumping. Finally, it was Kangaroo's turn. Everyone yelled, "Jump, Kangaroo, jump!" He closed his eyes, sprang forward on his big hind legs, and jumped just as far as he could. Kangaroo looked around in surprise as everyone cheered. Then Ruby announced, "Kangaroo not only won the long jump, he set a new camp record. Hooray for Kangaroo!" The end. So, that was a really interesting book, right? We went through the kangaroo as he's going on his camping adventures. He participated in a bunch of different events such as swimming and running and the long jump. And we saw how they divided everyone into different teams. So our question for today, what is one takeaway that you had from the read aloud? So you can go ahead and pause the video real quick and just share with anyone around you, whether it's a parent, guardian, friend. Just go ahead and share one idea or one thing that you got from the video. Awesome job, guys. So some takeaways that you could have had are that this book talked about fractions. As you're going through, we saw how each of the teams were divided up. So for example, when they were doing tug of war, they needed to divide into teams of 2. So 12 divided by 2 is 6, right? And that means that they had to split up in half, because half of 12 is 6. So we also talked about the similarities and differences between, well, actually more so the similarities between fractions and division itself. So this book just kind of goes over, obviously the kangaroo had a great time at camp, but we also learned about some fractions and like how fractions relate to real life applications. So here's our last question. What is a fraction? Well, we saw fractions in the book, right? As we just talked about, we saw that they did the tug of war where they were divided in half. So half is our fraction. So what is half? And I'm going to write it on the board here so that you guys can see what it looks like. This is our fraction 1/2. So if we say, what does it mean if we have a fraction of a half, for example? A fraction means that you have a part of something or a piece of something. So if we think about a piece of pizza, so if you draw out a pizza, you have a circle here, right? Now pizzas are usually divided into 8 slices. So I'm going to cut up my pizza. My favorite kind of pizza is pepperoni. I don't know about you guys. So if I have my pizza here, and we're saying how much this slice of pizza right here, how much is this? I'm going to shade it in. This is 1/8 of our pizza, because I have 8 slices of pizza, but I only circled 1 of them. So I circled 1 out of 8 slices of pizza. And that is our fraction, because we are saying we have 1 piece out of 8 pieces. And that's how it's related to pizzas. If we go back to our fraction of 1/2 and we relate it to the teamwork where they were doing the tug of war, we saw that each team was 6 people and there were 2 teams. So we were looking at 6 people is 1 team. So you have 1 out of 2 teams, you had to divide it in half. So that's what that fraction of 1/2 meant when we were looking at it in that instance. But great job, guys. So that's our read aloud for today. Now we're going to move on to something different. We're going to do some whiteboard lessons and also some practice problems to go with it. So I'm going to have you guys follow along with what we talk about. I'm going to describe more so like what fractions are and how they relate to one another. And I'm also going to have you guys write this down on a piece of paper, take some notes, and you can even solve this on your own as we go. So let's transition on over. Hi everyone. So let's talk about tape diagrams now. So I'm going to draw a tape diagram on our board, and we're going to work off of this for today. So, and remember, a tape diagram is essentially a bar. We also call these bar models. And it looks just like this, and we use it to divide it into portions. So we're saying that this whole bar right here is equivalent to 1, okay? So what if we divide this into 3 sections, right? I'm going to take this diagram, and we are going to divide it into 3, just like this. Now, the next thing that we should do is we need to label each of our parts, right? So I'm going to take my marker, and we're going to label each of these sections. Let's see, how many sections are there? There are 1, 2, 3 sections. So I'm going to label each of these as 1/3. And you guys can go ahead and write this on your piece of paper too. So we have it just like this. We have 1/3, 1/3, 1/3. Now let's write this out as an equation, right? We know if we add each of these sections up, so this section plus this section plus this section, we get the entire bar, right? So let's write out our equation for this. We are going to say 1/3 plus 1/3 plus 1/3 equals, now this equals 3/3, right? Because 1/3, 2/3, 3/3. So we're going to write it equals 3/3. But when you have the same number over itself, so you have like 3/3, or if I had 2/2, or 18/18, if you have the same number in the numerator as in the denominator, this is equivalent to 1. So 3/3 is equivalent to 1 whole, right? So we know that this whole bar diagram here is equivalent to 3/3, which equals 1 whole. Now, let's think about this in another way. What if I decided to shade in both of these boxes here? We could also say that these two shades plus this one box here equals a whole, right? So we can also say that what is this box plus this box? A third plus a third is 2/3, right? So we can say that 2/3 plus this 1/3 that we didn't shade, 2/3 plus 1/3 equals, what does it equal? 2 plus 1 is 3, and the denominator stays the same. So it's going to equal 3/3, which still equals our 1 whole. So as you guys saw, I want to go back and we're going to point out some ideas that we saw through this. We saw that if you add each of these boxes individually, it adds up to 1 whole, right? Or if you add like these boxes and then you add this box, it's still a whole. No matter what you do, as long as you add up all the little pieces inside, you're going to get the 1 whole, which is why these are called fractions. They're a fraction of the entire bar model. And that's essentially why the name was coined for it. So if we think about this, we can also apply this to other problems. So let's try this with a new bar model. So I'm going to have you guys go ahead and you're going to draw a new bar model below this one on your piece of paper. So we're just going to start out by drawing a new diagram, which is going to be our rectangle, just like that. So from here, we're going to divide it into 6 pieces. So if I divide this into 6 pieces, it's going to look something like this. Just like that. So I have 6 pieces, right? 1, 2, 3, 4, 5, 6. So if we're looking at this entire bar model, we know that this whole thing equals 1. So we're going to put equals 1 at the top because we want to remember that we are looking at 1 whole right now. So first off, let's label each of our pieces. So we're going to label each of these sections as 1/6, right? Because it's 1/6 of the entire bar model. So we're going to just write 1/6 inside of each of them. You guys can go ahead and follow along and do this on your piece of paper too. Awesome. Now let's write an equation for this. If we did 1/6 plus a 6 plus a 6 plus a 6 plus a 6 plus the final 6, we would get 1 whole, right? So let's write this out in equation form. 1/6 plus 1/6 plus 1/6 plus another 6 plus 2 more equals 6/6, which equals 1 whole, because that is our whole bar diagram here. So we can also write on top that 6/6 is equivalent to 1. Let's see, is there another way we can write this addition equation? Because this is a lot of numbers, right? Like it was okay to write a third plus a third plus a third. That wasn't too bad. This one took a lot of work though. So let's think, what if we did something different? What if we decided to combine these 2 bars right here? And if we combine these 2 bars, so say I take this and we get rid of it, 1/6 plus a 6 is 2/6, right? So I'm going to write 2/6 here. Okay. Well, this is still 1 whole, right? So we can also say that another addition equation is going to be 2/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, which still equals 2, 3, 4, 5, 6/6, which equals 1. So this still gives us our same answer, right? Now let's try doing something else. What if we combine these 3 right here What if we combine those three pieces together? What's 1/6 plus 1/6 plus 1/6? It's 3/6, right? So what we're going to do is I'm going to erase this, and we're going to combine these all into one giant piece. And we're going to relabel this as 3/6. So 3/6. Now this still equals our entire bar diagram, right? So what we're going to do is we're going to do a new equation. We're going to write 2/6 plus 1/6 plus 3/6 equals 2 plus 1 plus 3 is 6, and that's 6/6, which still equals 1 whole. So the purpose of this was just to demonstrate how you can have different size pieces inside of a whole, but when you add them together, it's still going to equal the entire tape diagram. And this is decomposition of fractions, because we decomposed this bar by 1/6. We decomposed it by 2/6 plus 4/1/6. And then we did 2/6, 1/6, and 3/6. Another thing that we could have done is we could have done 3/6 plus 3/6, which still equals our 1 whole. We could have combined these two diagrams together, the 2/6 and the 2/6. We could have erased this all, and we could have written 3/6. Just like that. Now take a look at this though, right? 3/6 and 3/6. Well, that means that it's both half, right? Because 3 is half of 6. So this would make sense that 3/6 is half of our bar diagram. That's why there's only 2 of these that need to be added together to equal 1. Awesome job, guys. So we're going to move on to a problem that you're going to do. Actually, we're going to talk about something else first, and then have you guys do a problem on your own. So let's move on to our next one now. I'm going to draw out my new bar diagram for this problem. I'm going to draw a new rectangle, and this time I'm going to divide it into 5 sections. Just like that. So if this is divided into 5 sections, each of our little pieces is equivalent to 1/5. So I'm going to write 1/5 inside of each of these. So if we look at this, let's decompose our bar diagram one more time. This is very similar to what we did in the last one, except we're using fifths instead of sixths. So, for example, if I decided to shade in these 2 pieces, I'm shading this piece and I'm shading this piece, how much would I have? I would have 2/5, 2/5, right? And that's these 2 pieces together. Now, what if I decided to shade in? Let's get rid of this. What if I decided to shade in 3 of my 5 pieces? So if I wanted it to look like this. 3 of my 5 pieces is 3/5. So this is 3/5. What if I wanted to shade in 4 of my pieces? If I wanted to shade 4 pieces in, and I decided to add this piece in, this would be 4/5. And I would extend my little symbol here, and we would write 4/5. Now, what if I decided to shade this whole entire bar diagram in? I would get 5/5, right? Because I shaded in 5 out of my 5 pieces, which gives us our 1 whole tape diagram. Awesome job, guys. So that's just another example of what we discussed in our previous problem. For our next problem, I would like you to work on this on your own. So I'm going to give you a new bar diagram. We're going to draw out a diagram, and we're going to divide this one into 8 different sections. So I'm going to draw a diagram. Remember, our bar diagram looks just like a giant rectangle. We're going to divide it into 8 sections. Okay, so I have all my 8 sections here. You guys go ahead and draw that on your paper. Next step, what you're going to do is I would like you to decompose this fraction into 2 different ways. So for example, I'm going to do one example and I want you guys to find 2 other ways. We're going to use a bond to represent our answer. And this is what a bond looks like. It's our circle at the top and it's going to have 2 circles that connect to it. So the circle on the top is 1 because this represents our tape diagram, which is 1 whole. So I'm going to write a 1 in my top circle. What we want to do is we want to find 2 numbers or more. We can also do more. We want to find what numbers added together equal 1. So for example, I'm going to put 3 circles here. Okay. So what we're going to do is we're going to say if I have an 8th, 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 and another 8th. How can I divide this up so I have 3 things that I'm adding together? Well, for example, I can add 2 8ths plus 1 8th plus 5 8ths, just like that. And I would put 2 over 8, 1 over 8, and 5 over 8. Just like that. Because when you add 2 8ths plus an 8th plus 5 over 8, you get 8 over 8. Yeah, you guys can have as many or as little connecting circles down here as you want. You can have 2 circles. You can have 5 circles. It doesn't matter. It's totally up to you. I'm just asking you guys to create 2 more bonds. So I'm going to start drawing them out down here. So I want you guys to fill out these 2 right here. So remember, we start with our 1 whole on top, and then we have connecting circles below it. So you guys, it's up to you how many connecting lines you draw. So go ahead and pause the video now, and then when you're done, I'll go over some examples of answers. Awesome job, guys. Give yourself a round of applause. You filled in 2 more bond circles. Let's go over some other possible answers that you could have came up with. So we did 2 8ths, 1 8th, and 5 8ths. Let's see, what else can we do? What if we decided to divide this bar diagram in half, right? If I divided this in half, I would draw a line right about here, because that's half of my bar diagram. So I'm going to draw 2 bonds down here, because we're going to say 2 numbers added together equal a whole. So on this side of our diagram, we have 1, 2, 3, 4 sections. So we have 4 8ths. And we have 1, 2, 3, 4 sections. So we have 4 8ths. So in my bond down here, I would write 4 over 8 and 4 over 8. Now let's try just one more example. If we did one more, let's say that this time I want to divide this up into 4 different sections. So I'm going to create 4 connecting circles down here, just like that. So if I did this into 4, what can I do? I can do these 2. So I can say 2 8ths plus, we'll do another 2 8ths plus, I can do 2 8ths again, or I can do 3 8ths. Let's try 3 8ths. So 1, 2, 3, we got 3 8ths, and then I have a final 8th over here. That's 4 numbers, right? Because 2 plus 2 is 4, 7, 8. That gives us our entire bar diagram. So I'm going to put these numbers into our bond down here. I'm going to say that 2 8ths plus 2 8ths plus 3 8ths plus 1 8th equals 1 whole, which is equivalent to 8 over 8. So those are just some examples of things you guys could have came up with. You could have done 2 8ths, 2 8ths, 2 8ths, 2 8ths. You could have done 5/8 plus 3/8. You could have done 6/8 plus 2/8. So like 6/8 plus 2/8, which still equals 8/8. These are just different ways of decomposing. You guys could have came up with so many different answers. These are just some of the possible ones that you could have created on your own. So we're going to go ahead and erase this, and we just have 2 more problems that we're going to work on, and then we are all done for today. So for our next one, we're going to relate this to multiplication along with addition. So I'm going to draw my tape diagram, and we are going to divide this one into 4 different sections. So your tape diagram should look something like this. So from here, we're going to label each of our sections. We're going to say that we have 1/4, a quarter, another quarter, and then a final quarter, just like that. So from here, if I shade in 3 of these sections, how much of this diagram do I have shaded in? Well, let's see. Let's add it together, right? We're going to add 1/4 plus 1/4 plus a final quarter. So if we wrote this out, we would have 1/4 plus 1/4 plus 1/4, which equals 1 plus 1 plus 1 is 3, so that equals 3/4. And that is how much is shaded. Now, we did that. Yay! There's another way of doing this though, and we're going to discuss it today. So if we look at this, we shaded 3 sections, right? Look at this top number here. This top number is 3. We shaded 3 of our quarters, and our answer is 3/4. So what if we did multiplication? What if we wrote that 1/4 multiplied by 3 equals, what does this equal? What's 3 times 1? 3, right? And then you leave the 4. So it's 3/4, which is 3/4. Because essentially this is 3/1. 1 times 3 is 3. 4 times 1 is 4. This gives us our same answer of 3/4. Now what if we had a bar diagram? Let's just do this real quick, where we divided it into 6ths. So I'm going to draw it out. We're going to have 1, 2, 3, 4, 5, 6 sections. So we have 6ths. What if I decided to shade in 5 of these? So I have 1, 2, 3, 4, 5. I could either write 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 equals 1, 2, 3, 4, 5. Oh, these are 6ths. Remember, because we have our bar diagram divided into 6 sections. This equals 5/6. That's kind of a lot of work, right? So what if I did 1/6, 1/6 multiplied by 5, which is essentially 5/1. What's 1 times 5? It's 5. What's 6 times 1? 6. Look at that. Our answer is the same whether we add or multiply our equation. So we have 5/6 and 5/6. So that just shows the similarities between when we're adding fractions together versus if we wanted to change it into multiplication. So for our last problem today, we're just going to work a little bit more on decomposing fractions. So let's create a new bar diagram, and we're going to divide this into 3 sections. So I'm going to have my rectangle just like this, and we're going to divide it into thirds. So we have 1/3, 1/3, 1/3. And if we add all these together, we get 1 whole because it's our 1 whole tape diagram. Now, what if I wanted to do something else? What if I wanted to break this section in 2? So I'm going to draw a little line down here. Dot, 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 dot. We are now saying that we have this section is in 2s. So this is still 1/3. This is 1/3. This is in half now. This we broke into sixths because we divided it in two. So we now have 1/6 and 1/6, just like that. So if I was going to write a new equation, I could say that 1/3 plus a third plus a third equals 1 whole. Or I could also say 1/6 plus 1/6 plus my 1/3 and my 1/3 still will equal 1 whole, because 1/6 plus 1/6 is equivalent to 1/3. See how it still fits into the 1/3 bracket here? That's totally acceptable. It just shows that these are smaller pieces when added together equal a bigger piece, which this bigger piece, when added, is going to equal this giant piece of one full number. We can also divide this into half, where we have our 1/6, and then we can divide this in half, where it's 1/6 also. So 1/6 times 6 pieces is still going to give us our full diagram of 1. And that just kind of demonstrates the decomposing of fractions and how that works. Let's go back to our slide for today, and we're going to look at the we're going to look at our overview of what we are discussing. So let's go back to our objective for today. If we go back to our objective, we're going to talk about how we discussed I can decompose fractions and whole numbers into smaller unit fractions by using a tape diagram and addition or multiplication equations. So we did all that. We decomposed fractions. We looked at how fractions can get smaller or bigger, how we can add them together, or we can use multiplication or division. And we also worked with the tape diagram, which is this model right here. This is also known as a bar diagram. Anyways, you guys did a super great job today. You did a wonderful job with learning your fractions and listening throughout our read-aloud of Jump, Kangaroo, Jump. Anyways, I hope that you all have a super wonderful day, and I hope that you learned a lot today.